Well, it's my great pleasure to be here. Just to take a few seconds about myself, I'm maybe one of the few engineers in the room, I'm not sure, so I'll try to represent that beleaguered group. But I'm a travel demand modeler, so most of my work I come at planning from a modeling point of view, and that's what I'm going to be talking about today. I thought I kind of took the topic of this session very literally in terms of measurement, and my assumption is that regardless of how we use accessibility in planning, I think there's going to be a lot of discussion about that and some of the issues. I think we need to have, one way or the other, we need to have measurements of accessibility if it's going to be useful, particularly if we're talking about economic, any sort of classical economic evaluation, or bringing it and perhaps replacing some of the mobility measures that we, as Phil has noted, we're used to. So I'm going to, for Monday morning, I'm going to inflict perhaps some methodology on you, and I'm going to talk about methods, most of which probably most of you are quite familiar with. So I'm not going to dwell on the methods themselves, but what I want to show is that, first of all, there are many measures, as I think we're aware, but I think sometimes we don't realize how related these measures actually are. In some sense, I'm going to argue that many of these are kind of special cases, and so I think it's important that we understand the assumptions behind the measurement methods to assess how valid they are, or how useful they are in different contexts. And it may well be that there is no one measure for all applications. And I think the behavioral assumptions implicit in these measures, again, are something maybe we don't always think about, and I think they are important. So I'm not going to try to address why we're trying to measure accessibility. I'm not going to try to address the planning issues. As I say, I think that will come, but I want to just get started with a bit of a foundation of something about these methods themselves. And I think we would all agree, but maybe this is something for discussion as well, is this definition of accessibility itself before we start to measure it. For me, accessibility is the potential for participating in activities, to interact with people and places. They're distributed over space and also over time. And I start with that very, very simple definition, very generic. And so to try to move towards explicit measures of how do we measure accessibility, I'm going to present what I'd like to call a few axioms that I think define, in my view, should define any measure of accessibility. And out of those axioms, identify certain key assumptions that we have to make whenever we try to operationalize the measure. And I think some of those assumptions are very, very critical. I'm going, as briefly as possible, try to introduce a typology of measures, and again, I think most of us are familiar with those, and talk about a few issues in using accessibility measures. And again, not social issues or planning issues, but just actually the technical issues, I think, associated with using some of these measures. So for me, I would argue that there's four axioms that I would argue that any measure of accessibility should satisfy in some way, shape, or form, or address. First of all, I think we would agree that accessibility is a point measure. It varies from point to point in space. We're located here. We have a certain access to restaurants or employment or whatever here. If we move a kilometer away, that accessibility changes. Just by using that example, I think we would agree that accessibility, at least as we usually define it, is activity or trip purpose specific. We have one accessibility to jobs from this location. We have another accessibility to hospitals at this location. And I think the third axiom is that an accessibility measure intrinsically involves mixing two things together, or looking at the combined effect of two very important factors. First of all is the ease or difficulty of traveling to or interacting with a point in space. How easy is it for me to get someplace? The easier it is, the faster, whatever, the better, more accessibility, but also the attractiveness or the size, the opportunity at that location. If I have a lot of really good restaurants close by, I have high accessibility to restaurants. If there are very few restaurants, or they're of poor quality, or they're far away, I have low accessibility. And so, as we'll see, accessibility measures in general work at trying to combine these two things in an appropriate way to tell us something about this potential for interaction. And specifically, they all, one way or the other, involve integrating or summing over the opportunity space, typically weighting those opportunities by the ease or difficulty of getting there. And so just if, let's, for argument's sake, we accept those axioms, say, yes, those are all sensible things to define accessibility, just within those words, there are at least four major assumptions or clarifications or definitions that we're going to have to bring to those axioms in order to actually compute something or measure something. First of all, what do we mean by ease of access or difficulty of access? How do we actually measure what, and we have different terms for it. We talk about utility or disutility of travel. We talk about generalized cost, maybe just plain old travel time or impedance. How do we actually operationalize that? How do we measure that? Second is, it's fine to say opportunities, attractiveness. How do we actually define the attractiveness or the opportunities available to us? And then tying into both of those is then what's the role of individual tastes and preferences and individual constraints on the ability to interact. If I do not have a car, the ability to interact using the automobile mode is severely restricted. I may prefer certain types of activities or be looking for a certain type of job and so forth. So the role of individual tastes and preferences typically enter in or can enter into how we compute things. And then finally, what is this opportunity set? What opportunities are relevant to this decision? Clearly, distance in some sense is important. I live in Toronto. Montreal is, I don't know, 500 kilometers away. Jobs in Montreal probably aren't very important in terms of determining my accessibility to employment. But as we move closer, at what point how far away does something have to be before I don't consider it as part of my accessibility set? So I want to talk about each of these just very, very briefly. What am I doing? Okay. And because and again, if we look at different accessibility measures that have been used over the last number of decades, we see various measures of travel impedance. Very often, distance is used. Many geographers still like to just use distance as a measure, how far away something is. For walk access, that's probably fine because distance directly correlates to travel time and also just the level of effort. But in general, we think travel time or some function of travel time is probably preferred. But as soon as we say travel time, this introduces a major complexity into measurement because travel time, as we obviously know, is mode-based. Travel time to one location by car is very different than by walking or transit. So all of a sudden this is introducing into a relatively simple concept, ease of getting there. Well, it depends on mode. So we have, at the same point in time and the same point in space for the same purpose, we have different accessibilities, at least by some measurements, by mode. So how do we handle that? If nothing else, this is introducing complexity into our calculation. And as we'll see, and as I think most of us know, we can extend this concept of time to a more generalized notion of the overall utility of travel, of disutility of travel. The issue of attractiveness, I think, is also something that maybe we don't often talk enough about. By far and away, in any practical measurement, almost always we use a size variable. The number of jobs, the amount of retail floor space, the number of stores as the attraction measure. And the assumption is the bigger it is, the more likely you are to find the pair of shoes you're looking for or find the job there. But inevitably, this assumes that the number of jobs or the number of stores or the square meters of floor space are all homogeneous and are equally attractive. So one location of a given size and another location of a given size are assumed to be equal in attractiveness, but maybe the quality or, there could be all sorts of attributes of those different locations that might in fact mean that one is more attractive than the other. And so this again introduces a complexity into the calculation in terms of just what do we mean by accessibility and how might we measure it. Again, I think personal level heterogeneity is extremely important. My preferences may be different than yours. My needs may be different than yours. My constraints may be different than yours. Many measures that we use in practice are very aggregate. We sometimes talk about location-based accessibility versus person-based accessibility. Those so-called location-based are usually aggregate and don't differentiate between differences among people, which are effectively assuming that everybody's needs, constraints, preferences are the same. So as we'll see, we can introduce this sort of heterogeneity into the measurement, but again, this adds dimensionality and complexity to the calculations. And finally, I think something I don't think we talk nearly enough about is the location choice set. Again, what opportunities are relevant to the conversation. This is a problem that bedevils us in travel demand modeling, our spatial interaction models, our distribution models. The question of how do people choose to go where is actually still, I think, a very open question. And so, and I think the final sort of general point I want to make that, again, I'm not sure is always recognized, obviously is sometimes, is the relationship between accessibility and travel demand. I will argue that every measure I'm going to talk about in the next few minutes has associated with assumptions about location or destination choice and or mode choice. That if accessibility is the potential to travel, then the accessibility measure should relate to people's actual behaviors and people's actual choices. And to the extent that we can quantify the parameters in the model, usually it comes from observing what people actually do and imputing their tastes and preferences, and hence how they value opportunities, how they value utility. And so I'm going to try to show a direct linkage to destination choice models, because I think this is, in a sense, the underlying behavioral theory behind any accessibility measure. Again, if a measure is to be valid in any sort of evaluation, I would argue it should tie back to human behavior in some reasonably direct way. So a very brief typology of accessibility measures. I think these, again, I think for most, if not all, people around the table, these are all pretty familiar with us. And we could, maybe there's some other measures people could talk about and different terminology sometimes. But I think these four are by and large, the way we tend to measure accessibility or try to in practice. The simplest is we just, the distance to the nearest location. So very often we'll see distance to the nearest subway station, distance to the nearest freeway interchange, distance to the nearest hospital. As that's a meaningful thing. That makes some sense. Transit agencies often say, have a rule that 95% of people should be within a 5-minute walk of a bus stop. So this is one simple measure of accessibility. It only loosely fits into my axioms, I think, in a sense. It doesn't consider size or attractiveness of the location at all. So whether the subway station is a major interchange of many lines or just a single stop along the way, it doesn't matter. And the cumulative effect of multiple accessible locations, I may be close to many subway stations. Surely that's a better thing to be than just close to one. So, we tend to use this sort of variable often as a variable in mode choice models or maybe location choice models, but I'm not convinced it's a particularly generalizable or strong measure. A measure that we use much more is cumulative opportunities or isochrones. We establish, a 30-minute travel time, and we count the opportunities that are within that 30-minute time. This is an extremely common measure that's used a lot. I would argue that this is consistent with a destination choice model that says I am indifferent to any to the travel time up to the threshold, and my probability of choosing any one location within that threshold is simply a function of the size of that location relative to the total cumulative opportunities. And my probability of traveling anywhere else is 0. So, that's a little diagram there that, the probability, if everything was equal in attractiveness, is uniform up to the threshold. Very simple measure, it's easy for people to understand, but I think it has serious behavioral implications, because it does assume that whether how far away something is doesn't matter within the threshold, and then as soon as you go beyond the threshold, it's irrelevant. So, simple example here, I'm at point A, I have a 30-minute threshold, case A is one example where all my opportunities are very close to me. The second, B, same number of opportunities, but they're spread around the periphery of my 30-minute threshold. And the third one is same number of opportunities, but they're all at 30.1 minutes, not 30 minutes or so. So with this measure, A and B return exactly the same measurement of accessibility, and C returns an accessibility of 0. And I think we would agree that that's just simply not a very, very, very plausible assumption about how people behave. Yes, I may be fairly indifferent between whether it's a 6-minute travel time or an 8-minute travel time, but surely A provides higher accessibility than B does. Further, and I think very problematic and something that people don't pay nearly enough attention to, is that what is that threshold? Is it 30 minutes? Is it 40 minutes? Is it 45 minutes? We see all of these in the literature. We've done some experiments using Toronto data, and we can show that the rank ordering of one zone's accessibility versus another zone's accessibility, the rank ordering of those, which has more accessibility, changes as the threshold changes. And so there's no consistent ordering across accessibilities between a 30-minute and a 45-minute or a 50-minute threshold. And I think that's very problematic, because it means our results are very arbitrary and highly dependent on our assumptions. The third measure, which again I think everybody's familiar with, is so-called gravity measures, often referred to Hansen's seminal paper, which go a long way towards addressing the problems with the isochrone method, in that now we weight the size of the location by an impedance function. And this gives rise to the so-called gravity model. This gives us a smooth sensitivity to distance. The further something away is, the less likely we are to go there, but we don't have that hard threshold. And so this is it's called a gravity measure because it's consistent with the classic gravity spatial interaction type model. Gravity models have been with us forever, well over 100 years. They've often been criticized for being ad hoc. Why should social interaction correspond to Newton's law of gravity? But in fact, gravity models have a very strong statistical foundation. They can be derived from information theory, and it can be shown that in the sort of limited situation of limited information we have, we're trying to explain a complex behavior with relatively limited data. A gravity model is generally a statistically least biased, most likely estimate of the spatial interaction. So in fact, there is a very strong statistical theory, not a behavioral one, to say that in certain circumstances, this is a reasonable way of representing spatial interactions. I would note at this point that both the isochrone and the gravity measures define accessibility as the denominator of the spatial interaction model. We have the spatial interaction model, the gravity model at the bottom, equation 6. The accessibility is simply the denominator of that. If we went back to the isochrone one, it would be the same thing. So accessibility, our definition is that it's the impedance weighting sum of total opportunities within a feasible set. We can flip that around, actually. If we started with that as a definition of accessibility, then the behavioral model that we're hypothesizing then is the probability of choosing a location is the ratio of its accessibility defined by its own little attractiveness and its impedance divided by the total accessibility. And so I think there is this two-way mutual, it's a kind of tautological definition between accessibility and location choice, that we choose highly accessible locations, and accessibility is defined that way. And so, while we say accessibility is not considered in traditional transportation planning, and I think that's true to a large extent in terms of our evaluation measures and how we speak about it. In fact, in our travel demand models, arguably accessibility is central to how we predict the demand that we're then trying to evaluate. Perhaps something to think about. And then finally, we have random utility measures coming out of logit models. And again, hopefully people are familiar with the theory of random utility theory. And I'm not going to try to go over that. The key point is that if we adopt a random utility theory point of view, then we can, as long as we're working with logit models, we can define the expected maximum utility of a trip or an interaction is the natural logarithm of the sum of the denominator in the logit model. And so we're going to show in a second that logit models and gravity models are mathematically the same thing. So the only difference between the accessibility measure coming out of random utility, fundamentally, and our traditional gravity measure is we transform with a natural logarithm. Why would we do that? Well, because the argument, the definitional, the assumption, the definition of accessibility with random utility is that how do we measure potential? How do we measure benefit, if you will, of this opportunity space? Well, it's the expected utility we'll get out of an actual interaction. Further,
another 4 minutes, yeah.
Okay, I'm almost done. Okay, so that lost my train of thought. It can also be shown that expected maximum utility is consumer surplus. And so I think there's a very strong economic argument hence it's a direct social benefit, social welfare measure. And it is in fact well known that gravity and logit models are, if properly specified, are exactly the same. And so again, we often see people talking about gravity measures, utility or logit-based measures. These are mathematically the same if they're specified the same way. And so I think there's often a confusion in the literature that we do one or the other, but they really are the same. We can extend, we can bring mode. So far I've been emphasizing it, but everything I've been talking about is using a single travel mode, the travel times for a single mode. We can extend this to a multimodal situation by using a nested logit model in which we get a mode for a given destination. We have a modal accessibility defined over all the modes, which is a log sum term, and then we can bring that up and we compute the accessibility to all the locations given the modal accessibility provided by that. So this provides a very generalized framework. We can handle multiple modes, we can handle multiple destinations, and I haven't emphasized it, but the heterogeneity, this can be a disaggregated model where individual people with their individual tastes and preferences are having their accessibilities computed. Just to illustrate this, I'm not going to even address this, but this slide is showing a nested work, location, and mode choice model from which we can then compute accessibilities. I am running out of time, so I think in trying to apply these models, these methods, I think there's a general lack of understanding of accessibility among people. I once made the mistake of trying to explain a random utility log sum accessibility measure to the chairman of our regional transportation planning agency, very bright man. You never saw eyes glaze so quickly, so we have to explain these things. I think there's discomfort in many planning agencies with some of these methods, but I think the 2 points I really want to make is, first of all, and again, I think this is something we don't spend much time talking about, is utility is an ordinal variable, not, if we want to use a utility measure, is ordinal, not cardinal. And so there's no absolute value of utility. So if we increase accessibility by 5%, what does that mean? What's the absolute measure of that, I think that's, we don't really know. And so, because there are, any model is only relative to its own context, and let's say we have an accessibility measure for one occupation group and another occupation group. If they're separate models, those accessibilities in fact are not directly comparable in terms of calculation. But it turns out there are methods to actually sort of descale the hidden scales in these models so that we can in fact directly compare accessibilities from one to another. So and again, this is just, I'm not going to discuss it, but this is something we have an example of where we build models for different occupation groups, different accessibilities, we descale them, so we can then now say, do professional workers have better access to jobs than manufacturing workers, for example. And then finally, I think even if we descale, however, there's a question of in these utility-based measures, are we really capturing utility? If we're just using size variables, again, these are really assuming that every location, let's say each job in each location, is identical in terms of its attractiveness. And I think we need to do better than that in terms of trying to really capture accessibility. And finally, the final point, I think this is something I've seen at least in one other paper, perhaps if we really want to get an economic value for accessibility at least, maybe we really have to be looking at residential location choice models, firm location choice models in which these accessibility measures enter into people evaluating different locations and demonstrating how much value they put on accessibility versus all the other attributes that are going into their location choices. And there's examples of this in the integrated transportation land use modeling. And finally, just the last little point, everything that we're talking about here is trip-based. The state-of-the-art in travel demand modeling is activity-based modeling, where we look at the entire activity patterns of the entire day of all people in a household in terms of all their interactions. Arguably, if we want a more holistic view of what's this household's accessibility, maybe we should be looking at these activity patterns over the course of an entire day. And so there, Mr. Chairman, I've probably used a few more minutes than I should have, but I'm done.
Thanks very much.